Fine? Cool. Folks, hello everyone. My name is Ankit Upadhyay and I work for ThoughtWorks itself. It's been around 7-8 months now since I've been working with the GenAI team itself. And yeah, so the topic for today would be generative AI with knowledge graphs. I think pretty much is covered. All of the speakers actually pretty much covered everything. Shiv actually gave a great demo. But one thing about me is I love insights, some of the facts. So, when you go through different websites, you get different facts, give different things, right? Probably generated by GenAI too right now because that's the theme everywhere. But yeah, let's head over to CNBC and we see one fact that over half of the employees have no idea how their companies are using AI. Okay, that is around 54% of people actually don't know what, or maybe don't know how does AI actually work. So based on that, I think folks have pretty much covered almost all of the high level things. I'll go bit into, okay, what GenAI is regarding that. We're not in the, we're in the 54%. So yeah. So the agenda for today would be talking about generative AI and LLMs. Then we'll move ahead to how do we ground LLMs with knowledge graphs, what grounding actually means. And then we see a demo that we created for ThoughtWorks, a POC that was created by our team for ThoughtWorks itself. Okay, just on a short note that if anything goes down or it breaks or if something doesn't work, it's probably again generated by GPT. So I'm not the one to blame here. Cool. Okay, so I just want to ask you one simple question. Does anyone know the difference between when we say generative AI or when people were talking about LLMs? Does anyone actually have an idea what an actual LLM is? Or let me just make it straightforward. What do you think is ChatGPT? Is it an LLM or is it a generative AI application? Okay, one answer we got here was an LLM. Anyone else? Okay, it's both again, okay. Okay, so generative AI, as the term itself is defined as a system that takes in a prompt and gives us a fairly simple answer if you say so. So ChatGPT does the same thing. So it's a Gen AI application. Under the hood, how does it actually generate answers is where, people say it something of a black box kind of thing, but I don't think it's all of a black box when you understand. It's an algorithm that generates something, okay? It's an algorithm which takes a piece of data, has some, high level or low level concepts such as neural networks and stuff, and then generates something. So under the hood, it actually uses a large language model, which is pretty much defined as an algorithm that takes in something, builds some neural connections from it, and then gives you a certain output. So GPT-3 or the models that we talk about are actually the large language models, what Shiv was also showing, the LLM kind of thing. So yeah, so the models are basically the large language models here. Now, again, so LLMs are the crux of everything here. When you see LLMs, it gives a lot of opportunity to create or build a lot of different things, automating different tasks, or maybe when you're querying about anything general about whatever data that it has. If you want to talk about what is the capital of India or who's the Prime Minister of India, it would have certain information for you. Then it could also be used for improving customer service experiences. Let's say creating a conversational bot, having FAQs directly being taught instead of you going through all the 20-25 FAQs and you don't find anything any relevance to it. Apart from that, it also has expedite reading, understanding, and summarizing, which is its core thing to do. It summarizes text very well. Any LLM that you go through, be it any open source LLMs or any state-of-the-art models, the crux of it is it's very good in summarizing text and basically generating text. And as I said before, generating code, which it's not the best, but it has the capability to generate code as well. So yeah, you remember the first point that I said, right? If anything's written, it's probably GenAI. Kidding, guys. Cool. But how do we actually use it? How do we actually make use of all these large language models that we have? We see how he displayed. We have search engines, or we have GraphQL AI models as well. Generating ciphers, but what if I want it only for my context? What if I wanted to build it only for me, or for enterprises, for companies where, you know, data is the crux. I can't send all of my private data to, you know, let's say OpenAI. So there are some challenges using LLM as well. First one is knowledge cutoff. Now when you go to ChatGPT and ask something which it doesn't have any information, which I think it's from September 2022, something like that. I mean that's what I'm thinking, but yeah, it doesn't have any, you know, corpus of data beyond that. So now when you ask something recently what happened, it won't have anything which it could provide information to you. Second, it gives you reasonable answers, but not always accurate. For example, the facts that we were talking about. Search for a fact and you'll get thousands of websites. Search again on LLM because, okay, and then we think that it's correct. But, you know, there's no standard way of saying that it's the most accurate representation of all the facts that we have. Okay, and one of the main points is that it can inherit bias through training data. So whatever training data it has been trained on, okay, that gives it an edge. For example, GPT 3.5, all the Twitter public domain for all the general corpus of data. Now, what if I only wanted for my specific set of questions, nothing else? Maybe if I use OpenAI and don't provide any data, it would give me some certainty bias because of the training data that it has been trained on. Again, as I was mentioning again and again, there is lack of enterprise domain knowledge because, yeah, I mean, I don't want my thing to move out, okay, from my ecosystem as well. And then inability to verify or attribute sources. Again, if I am getting any facts, if I'm asking GPT or the ChatGPT any facts about it, it can give me certain facts, but I don't have the ability to actually verify that source. Where is it coming from? Okay. Okay. So now, I mean, this AI movement, you know, everyone's using AI, Gen AI, it's around the corner everywhere. I don't think there's anyone in this room who has not heard of Gen AI. Even Dan's site has graphqlai.com. Come on, guys, it's AI itself. But the thing here is, how do we actually use it for ourselves? This technology getting so ahead. So is there any way to solve this problem of knowledge that we're talking about, to use it for our own cases, for our, you know, knowledge bases, databases, etc.? The first and foremost thing that one can try is, again, fine-tuning different models. Now, what does fine-tune? Just get in your data, put it in the model, and fine-tune it based on whatever you need it. But it's, again, it has its pros, it has its cons. Obviously, it's better, but again, it's costly, and I don't think much of our use cases, I mean, the general use cases need fine-tuning as well. The second approach that comes into place is actually grounding knowledge with all these LLMs. So what does grounding knowledge actually mean here? Now, before we deep dive into, okay, what this grounding knowledge is, and when I show you a certain brief demo, let's once again, I mean, as Shiv has already talked about it, I'll just brief you again shortly. So what are knowledge graphs? Knowledge graphs are nothing but, let's say, building a very natural relationship. For example, let's say I'm here, okay? I am the speaker, and let's say Daniel is, again, you know, one of the speakers of this Neo4j event. We both can have a relationship directly to Neo4j event, right? So that relationship that it builds is very natural and can be, you know, basically you can think of it. You can see it's more humanly possible, okay? And there can be various and, I mean, humongous type of relationships that you can think of. Me and, you know, someone sitting in the audience can have a relationship of something. Me, Neo4j can have a relationship, and so on and so forth. So, I mean, taking all of these data into places, okay, be it structured data, be it unstructured data, you know, be it different file formats, etc. Based on that, we can actually have various different kind of relationships, and that is what primarily what a knowledge graph actually is. It's just in a very simplistic way, it is two nodes having a relationship between them. Expand it up to your horizons, build nodes, build relationship. That's the whole crux of what a knowledge graph actually is. Now, let's say when we were actually, you know, coming across different, there are different type of graph databases, we came upon Neo4j because the three things that it stands out is of connect, enrich, and consume. Now you can connect Neo4j, it's basically context rich. You can create any source of, like, you can take a file, it can create relationships. You can take any amount of data basically, and it could create nodes and relationships for you. Basically you either giving them, or there are different ways that, you know, Shiv has talked about, or maybe, I mean, that you can figure it out. Just don't ask GPT, just use Google also. Cool. Then second foremost is enriching. So as he said, there is a GraphQL library as well in Neo4j. There's now coming up graph data science libraries as well, which I don't think so you get it in the community edition, but there are different data science libraries. You can actually find different paths also. For example, Neo4j happening here, Neo4j in London. What were the common people who also, you know, joined both the events and stuff? So it actually takes all of your data within different libraries, different communities coming up and creating different libraries. It actually enriches your data very well. And the third is actually consumption. So you can consume all of these data based on search, okay? Neo4j has also come up with vector indexes in its the DB as well, in the database as well. So it makes the search relevance also much more cleaner, much more higher. So it actually gives you a one-stop solution to try it out, to, you know, build POCs, to have it in the enterprise and, you know, create applications of your sort. Now we were talking about, you know, everyone here has talked about something. Shiv has talked about, you know, e-commerce, data, knowledge. But what is this data and what is this knowledge actually? What does it actually represent? And for that, before coming here, I'd just like, if anyone's on their laptop, to actually, you know, just try this on a very high level overview. Let's say if I ask, what is the capital of India? You see, we get a very direct answer saying New Delhi. I don't think anyone who knows this would ever scroll down, correct? Would ever scroll down, okay, what do I need? This is basically what you call a contextual search, because you're asking the question in the form of a context. You directly want an answer saying, okay, what is the capital of India? That's a sure short one thing answer, that's it. So this is where you actually give it a context to it, that, okay, New Delhi is the capital of India, and you get it very well. But now let's say I search for apple, that's it, apple. If you see here, I might be searching for the apple fruit, for the fruit apple, but the first site that I get is again Apple official site. Again, re-ranking and all out of the scope, but you see, this is what you call semantics, okay? When I move down, you see Apple has a lot of things. It can be a company, it can be an organization, it can be iPhone, which is again, you know, it's an alias to iPhone as well. Or basically, you see, you get different videos, but when you go to images, you can see Apple here. Now, I wanted to search for this apple, but Google, you know, doesn't know what are you actually trying to mean with Apple. I have so much of information with me, I'll just throw in everything that I have. And this is what you call semantics, where the person doesn't know what I want it, but it throws you everything related to it. So Apple could be, I could search for iPhone, I could search for all these fruits, I could search for the organization, so on and so forth. So, yeah. So, coming to this, we have semantics, okay? Then we have context. So now this semantics, right? It is what actually vector databases do. There's nothing apart from semantics that vector databases in general do. You throw in something and it just gives you the most relevant documents, as he said. That is what you call semantics, the meaning out of it. Second, but let's say, okay, we'll talk about this in the demo, how vector databases, and I think it will answer your question, why vector databases, you know, refuse, you know, there are limited. But then we also have, you know, fairly different graph databases as well. Now, these graph databases, if you see, are actually, you know, pattern matching, or maybe if anyone has, you know, heard about different graph traversals, they're very limited to context. Find people, find places, how is one related to other, or what is the capital of New Delhi. So India could be a node, New Delhi could be another node, and the relationship would be a capital. So that's how knowledge graph actually works, and that's the gist of a graph database. Neo4j actually gives you best of both the worlds. As I already told you, it already has vector indexes now inbuilt in it. And since it's a graph database, its primary focus is also on the context to find different relationships, different paths among your you know, knowledge graphs as well. So now grounding, okay? So now when we were talking about context grounding and this knowledge retrieval, I'd like to show you one more example here. Okay, let's say I'll ask him what is the capital of India. Okay. Now, based on its general corpus of data, ChatGPT itself said, okay, the capital of India is New Delhi, which is very correct. Okay, but for my applications, my application is just to fool users. It's just random jokes. Okay, I don't want it to say the capital of New Delhi is India. I don't want its general data to come in between and rectify what I want. I'm more intelligent. It's my application. I want the answers. So what I'll do, let's say, I'll just write based on any context, please do not use your general knowledge. And then if you see, I just used a random context saying blah, 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 blah. But in the middle, if you see, I just wrote the capital of India is Mumbai. This is what context actually means, and this is the whole concept of a context grounding. When people don't have that ability or that much resources to fine tune, this is the architecture that they prefer. So this context grounding, when you come here and let me just rerun this. Let's say, okay, see? And people say it's intelligent. But yeah, so the capital of Mumbai, India's capital is Mumbai, as I stated in my context. So this actually grounds your context and makes your knowledge retrieval as focused as you want. Okay. Moving ahead. Okay, so how does this knowledge retrieval actually work? Okay, so a very high overview is you build, you take in an application, a user asks a question, okay? It can be any question. It could be context, what I asked, or it could be anything very general. Let's say, what is this, or what is X, or what is, a platform, anything as such. This converts it into a vector, okay? And the vector index, as I told, is already again inbuilt in Neo4j. It's very easy to keep all these vector indexes at one place. And now, these are actually implicit results. Because let's say I want my information, and then I want my graph to actually, build connections to it. Okay. So let's say we got all the 5 nodes that are in blue. If you can see, we got that as an answer from our vector index. That is our top k results. How do we actually connect all these dots? I want my answer to be actually verified and actually reliable in case. So I actually take all of these and I actually map it out with the graph query itself. Okay. Taking both of these results, we give it to the LLM. And now, as I said, people actually confuse this, that it's very, it's very intelligent in this case. But the whole concept of context grounding is actually giving the LLM an answer. As you saw in my ChatGPT example, I already told it that the capital of India is Mumbai. We're already displaying the information to GPT, and we're just telling it to give us a very natural level response. That's the whole idea of context grounding and how in general architectures work. So, yep. So this is the architecture which, all of the blogs, even if you come across, all of the YouTube videos you come across in this whole space, search for chat with PDF. This is the architecture that you actually get, okay? And this architecture, when a user has a prompt, the prompt is actually given to a LLM API. It could be to embed it, it could be to generate text, it could be for anything which a text can basically do. And then, for example, here we're generating cipher for Neo4j. So this Neo4j then produces relevant results by using the implicit and explicit diagram that I showed you. And then it takes the prompt and that relevant information together and then gives you a response. So the response is already being fed by us to the large language model. What it does is it actually creates a good, way of, speaking it out to the users. So all in all, 3 steps majorly. One is to retrieve relevant results. Second is to combine all these relevant results and then instruct the LLM to only use that relevant results and give me some information that I can make through it. Okay. So this is the most basic architecture that you'll ever come across. Any blogs, any YouTube channels, if you're starting with Gen AI space as well. Okay. Yep. So we'll be heading towards the demo, which is a search TW blog, which we actually created for our POC, and we'll see why also vector indexes or vector databases in general do not work for a large, when you wanted to scale it with different questions or coming up with different use cases as well. Okay, so before going to the demo, I just want to also brief you something about LangChain. Has anyone ever used LangChain here? Oh, you've used LangChain. Okay, everyone, yeah, everyone uses, because that's the only framework here which gives you the app. I mean, not the only framework, but yeah, it's comparatively easier to use, developer friendly, plug and play. Okay. So LangChain, will take everything from the LangChain Cypher module. So LangChain already has a Neo4j integration within itself. So we can directly, use Neo4j, use all of its tasks, use all of its libraries as well within LangChain as well. And whenever the user asks a question, the whole thing would be going through LangChain itself. It will take, basically generate any Cypher query that is there from the Neo4j database that we'll initialize. Coming back, it will retrieve all those results, summarize it, and then, give it to the user. So the question translated to a Cypher statement, bringing relevant results, and then giving back to the LLM, which gives it back to the user. Okay, so we'll be using GPT itself as the large language model here. Everything here is on the public domain. So that's why we've used GPT, or else private data, you can use the local large language models as well, if you've gone through Llama, Falcon, Mistral, anything. Okay. I think it's here. Yeah. So before I show you the code, I just want to brief you on what this actually looks like. Okay. So again, as everyone spoke here, and this is again graph, and if anyone's starting, we just think of it as two different entities coming together. One is the node, second is the relationship. So nodes are singular, they're not connected unless and until you connect it out. Okay. So let's say we'll start with authors. Okay. Let me limit this to 5. And you see, we have 5 different authors within us. Okay. Let me just do it once so that we can focus. So let's see. So this author, and all of these are properties of that author, as the name suggests. Okay, it's all properties that you can fetch even. So so Matt being one author, maybe he has written some blogs, but I, being a very new person in ThoughtWorks, I don't know anything about him. What I can do is I can actually click and see, okay, is there anything that he has written? So if you see, now we get something different here. You see, now we get an arrow. This arrow actually represents, okay, let me just, okay, yep. So you see, we now get an arrow. Now this actually connects this node to Matt. And what is this node? It's the color, it's a blog. So this blog is actually written by Matt. And you get a very good natural relationship, and you can think of these use cases as in, let's say, communities, right? If you want to have a community engagement program, you can just switch out and just have a theme like who writes most of the blogs, and it could be a GenAI application which internally takes all of these data and puts you in the leaderboard, that who is the person who's writing what number of blogs or what domain has he written on. A lot of questions, a lot of use cases that will come through. So this is all about what Neo4j's web version looks like. Okay, so we'll go back to the code right now. Is it visible, right? And as you can see, we're mostly using LangChain, okay? And it already has a Neo4j graph already present. So we'll make use of this. And second most important thing, we'll also make use of the Neo4j vector to understand how different is it for the questions or for the use cases that you people might be thinking of. Okay, we're using again OpenAI embeddings, and we're using the chat OpenAI, which comes again within LangChain, where you can use OpenAI to converse through it. Okay, so this API keys, it's already there, but I've just created it randomly. It's gonna be deleted, but yeah, fine. Okay. So let's say we give a username, a URL, and a password. Initially, whenever you install Neo4j, it would be running on 7687 port. So that's the initial port. You give it a username. You might give it a password as well, and then you actually initialize your graph. So Neo4j graph with your URL, username, and password, and then basically, as per the diagram, if you see, we actually create a vector index. Okay. Now this vector index, we give it the embeddings, we give it again the URL, username, and password. We actually name what would be the name of the index that we're creating, and the label of the node that we want to create. And then we'll also specify the text node properties on which the embeddings would happen. Okay. And then we'll just name the property whatever you want to name. I've named it embeddings. We're using a very basic prompt for this, which is coming again from the LangChain's hub. which is again a community version where people, write different prompts. So I'm just using the rack prompt here. And I'm using GPT 3.5 Turbo, as you can see, with the temperature when he was talking about parameters, so the temperature, I've mentioned it as 0 so that it gives me same relevant answers again and again, okay? And then I've created a retriever where the retriever is actually the vector index itself. Now, okay, now let's run this, okay? So first, I'll show you by running this, okay? So now when you see, this is a very general question, right? Yep. So you see, this is a very general question. Yeah. Okay. So this is a very general question. If you can see, it says that what is platform thinking? Okay. I mean, it could be asked to anyone, anywhere. Okay. But we want it in our context. So now let's say, so if I run this, there would be some warnings. So yeah. Yep, and you get a whole lot of text from here, okay? So if you see, you get a whole lot of text here where your context is now provided, right? So this is the context that it has, and now we can take this and put it into any LLM and it will just summarize it or reformat it in a better way. So all of these contexts, if you see, the answers you could find it here. The problem here is, let's say, even if I don't specify anything, right? Even if I, let's say my context is something else, the data that I've given it is something else. Let's say it's about ThoughtWorks. But now, let's say if I start talking about Neo4j, it will still give me some responses because only relevant documents are created, which is again with your, what do you call it, with the top K value that you want, okay, with the cosine similarity. So there would be, every time, whatever similarity you give, there would always remain some documents that would be fetched, okay. And then we make use of different prompts, which I don't think, in my opinion, is the best way. We should actually focus on context grounding rather than changing the prompts every time. So, so one example for this that we came across and why we chose to go with this, let's say now I'm asking, what are the total number of topics available? Now this should give me an exact answer. Now I want to have a very streamlined flow that this is the topic, this is the author, this is the blog that I want to read about. But if I ask this, and let's say if I put it into a vector search, let me just clear this out. Yep, see, it would again give me something, but it would never give me the answer. This would be the context, okay? Please look at a feature request from a customer defect, because it thinks that this the whole text is actually similar to all of these contexts, which is abruptly not, okay? So now here, to solve this problem, we wanted to make use of both the things, right? So now let's say, okay, now one thing, as Daniel, you were asking him, how does it know the schema, right? So again, Neo4j again has it. That is why LangChain also has it, because it's a wrapper of Neo4j. It has something called refresh schema, which actually prints out the schema for you. And when you talk about generation, right, you can actually give your own relationship, build your own nodes, which I did. And then you can use a query to actually have the cipher generation template where you actually provide the schema within you, okay? So the schema is coming from Neo4j directly itself. You don't have to go and, build or write it out. So based on this particular schema, and as Shiv actually mentioned, which is a very good way of prompting, and it should be used as actually few-shot prompting, you can actually have different examples here, okay? So let's say this is one example where I say, where can I read about context setting on blockchain? Okay, and it gives me this particular, and I tell him that please fetch this particular query. Okay, so based on these examples and based on the schema from the prompt, you can actually generate different queries for yourself. So we'll see it out. So now let's say, what if I run the same question? Okay. You see, if anyone can see it, right? We get the total number of topics, 55. Now I have a very direct answer that, okay, these are the total number of topics available to me. Okay, so this, let's try out some other questions. Okay, now how about when we spoke about, let's say, context grounding? Okay, how do we know that it's not taking something else, you know, not just fetching randomly from the internet. Now, let's say if I write this, who wrote software governance in the age of Gen AI and citizen developers, and where can I read it? Now, this might work, this might not. If it's there, still there, it will. Let's see. Yep. So as you can see, yep. Okay. So as you can see, this is the query that it generated, which is absolutely up to the mark, and it also gave me the author and the source where I can read it. Now, from this, you actually know that okay, this is reliable. This is the source that we're getting it from. This is the author, and this is my data what I've used. So when you now, you know, you can just go to this link, and you see you open the ThoughtWorks blogs page, which the data was actually trained on, where the architecture we've grounded it on. So, yep. So this is what helps you, you know, this is what actually helps you when you're using a graph database or Neo4j in specific, where you get best of both the worlds. Based on your use cases, you can actually, you know, switch between different questions as well, when to actually use the vector index and when to actually use the graph index. So that's again out of scope, so we'll just move ahead. So all in all, as everyone mentioned, or I'll just take everyone's piece and then just summarize this. Any data source can be, you know, captured. It could be GraphQL, it could be any e-commerce website, any ThoughtWorks blog, any source of data could be captured, and you can, you know, extract it, building your own pipeline or building different, using different ingestion systems, Google Vertex AI, Azure Open Service, and then with the help of different graph databases, let's say with Neo4j, you can enrich these models as well, enrich all of these data. You can use graph data science, or you can again use Bloom. Okay, and then the last step would actually be the searching part, where you can actually have semantic and contextual search both based on it. So you can have different intelligent apps being built. You can have knowledge search, customer service, different FAQs, different you know, clinical decision support systems, anything and everything that you can actually think of. So it's just not limited to any textual corpus of data. You can take out anything and then build if you have good relationships within them. So that's all. Any questions? No questions? Cool. Thank you very much.